we had started doing elimination reactions. What we are going to do now is we're talking about halogenoalkanes. We're done with most of the halogenoalkane reactions. What's left is what's left in halogenoalkanes. What's left is uh, are the uses of halogenoalkanes. So halogenoalkanes and the uses. So we're going to discuss the uses. The first thing is, okay, when you're talking about halogenoalkanes, the first thing that comes to mind is CFCs. These are chlorofluorocarbons. Carbons. Now, chlorofluorocarbons are a very important class of chemicals because they are unreactive, first thing, and they are volatile, mostly volatile liquids. So they were frequently used as coolants, refrigerants, in deodorants. Now remember that water is a very bad solvent. Uh, Water is the reason why water is a very bad solvent is that water is highly reactive. It's highly reactive. I said there's a thing called freons. I said water is highly reactive. You don't want water around in a lot of things, especially like a coolant, because water can cause rusting. It would react with the metal. So water is very reactive. So water is a pretty bad solvent, which is why people came up with CFCs. TK, if you have a refrigerator, if you have an air conditioner, and it needs a coolant, the air conditioner pipes are going to rust very quickly if you start using water. Instead, you use CFCs. The problem with CFCs is that so why are they unreactive? First thing, the reason they are unreactive is that if you have a CFC, like if you have a carbon with a couple of fluorines and a chlorine, it's kind of a non-polar molecule because the dipoles would pretty much get cancelled out. So dipoles almost cancel out. And if your dipoles they cancel out, then it's not going to attract a lot of things. Doesn't attract other molecules. So it doesn't attract other molecules. Unlike water, like water is a highly polar molecule. TK. Water can form hydrogen bonding. Water would react with pretty much anything that comes close to it because it has a very strong partial negative charge and the H is very strongly partial positive. So the water molecule is highly polar. It's going to attract a lot of molecules to it, which is why it's a it's a very bad solvent. But coming back to the CFCs, now in now the other thing about CFCs is uh, that the bad thing about CFCs is that they cause ozone depletion. So they're going to destroy the ozone, and you must know the equations. You must know the whole process of the destruction of ozone. That's going to come in your exams too. How are ozone and what is ozone in the first place? Ozone is O3. It's a very harmful, actually. It's a very poisonous gas. Uh, but luckily, it's not present in the lower atmosphere. Present in the upper atmosphere. Okay, so it's present in the upper atmosphere, and it reflects UV light. Okay, we all know that because it's like a hazy substance. Uh, and also remember, in the lower atmosphere, So in the lower atmosphere, it is present specifically in cities. In the lower atmospheres, it is present in the form of smog. Okay, so you have this. If you look at a city from outside, you would always see, like, if there's a city with tall buildings, right? Let's say that's the central business district. You would always see, like, if you're coming from the motorway and the city is approaching, you would always see this smog encapsulating this city, this hazy dust-like environment around the city. Uh, and in a lot of cities, the smog issue is pretty bad. That even visibility, it actually looks like fog. The visibility reduces it reduces a lot. So it is present in the lower atmosphere. It is present in the form of smog and causes breathing problems. ठीक है, asthma etc. That is caused by that and causes breathing problems because it attaches to the hemoglobin. It messes up your hemoglobin, and your blood is not able to carry oxygen as efficiently as it should. Why is it present in the lower atmosphere? Because lower atmosphere, your cars, they produce, like, cars burn up because of the heat. The cars, they burn up air. Nitrogen and oxygen are able to react with each other. Otherwise, like, because of the, like, the air already has nitrogen and oxygen, but they don't react with each other because nitrogen is very inert. It has a very high activation energy, but because of your cars, they produce so much heat that the nitrogen and oxygens, they react to produce oxides, like nitrogen oxides, NO2. And NO2 is a very good oxidizing agent. It also plays a role in acid rain. So it's a very good oxidizing agent, and what it would do is that it would react with oxygen and it would convert that oxygen into O3. And that's your smog. Okay, so O3 is pretty bad in the lower atmosphere. It should be there. But in the upper atmosphere, that hazy thing that you see around the cities, that fog-like smog that you see, uh, you want it in the upper atmosphere. You want less sunlight to actually less UV light to reach the Earth's surface, because UV rays are very, very powerful and they're very harmful and they break a lot of bonds and they cause skin cancer. Okay, so it causes, like, in humans, it causes skin cancer. I say, anyways, coming back to ozones. We've talked about ozone. How does a CFC destroy ozone? You have to remember all these equations. Is this clear so far, Mohammed? Is this clear? Isaac, clear?
Yes. Could you just like explain on how NO2 can form acid rain again?
I said the acid rain part, like the whole acid rain.
Yes.
Just one second.
Yeah.
I'll just, since we are talking about pollutants, let's talk about that. Uh, where does acid rain? Like, acid rain begins with two things. One is that you have SO2. Where do you get SO2? You get SO2 from volcanoes. That's one. Okay, that's one. And combustion of fossil fuels like coal, like all your unrefined fossil fuels, especially coal, that contains, especially in countries that produce a lot of electrical energy through coal, there is a lot of SO2. There's a lot of smog. So combustion of coal or fossil fuels, just right, fossil fuels. Um, the unrefined one, and NO2. I just told you that you get NO2 from lightning strikes when air burns up, which it usually doesn't because nitrogen is very unreactive. So lightning strikes and car engines, they heat up. ठीक है, remember you get pretty large questions on this acid rain, ठीक है, in your papers. So you have to know everything, and they're going to ask you about everything, ठीक है. So it's uh, so air burns up to form NO2. So that's the first step. Then what happens? What happens next is that SO2 and NO2 they start reacting with each other. And NO2 is a good oxidizing agent, so it loses the oxygen and gives it to SO2, which ends up forming SO3. The NO can get oxidized back again because there is air, there is oxygen. 21% of air is oxygen, and it would be converted back into NO2. So NO2 molecules they act as catalysts. I mean, they act as catalyst and slash oxidizing agent because they are reformed or regenerated in the process. So that's how SO3 is formed. The next thing is how is acid rain produced? So finally, you mix them in water. So acid rain is going to be produced if rainwater water reacts with SO3 and it ends up forming H2SO4, or even NO2 reacts with water. NO2 is not as soluble. It's basically acid rain is basically sulfuric acid, but it's also going to form nitric acid and nitrous acid. Okay, Mohammed, is this clear?
Yes, it's clear. Just the equation with N2 plus O2, isn't it? N2 plus 2O2.
No, that's going to be two. I did not balance it.
That's okay.
Okay, it's going to be yeah, it's going to be 2O2. Okay, that's it. So you're going to get questions on this on acid rain. You have to write. You pretty much. I mean, this is all about acid rain. The other thing that's left is about acid rain is that you need to know the harmful effects, which you probably still already do. What are the harmful effects?
Is it like corrode marble and all?
Hmm.
Corrodes marble statues.
Okay, so it corrodes marble, limestone, metal.
The pH of water.
Okay, makes the water acidic. Water and the soil becomes acidic. And what about humans? It causes skin and eye irritation. Skin and eye. So it causes skin and eye irritation. So these are the harmful effects of acid rain. Okay, is this clear? So that's all about acid rain. Coming back to CFCs now. Okay, we were at this point that you had ozone. Mohammed, is that clear? Okay, we're done with acid rain.
Yes.
So now CFCs. I talked about ozone and how would a CFC destroy ozone? The first thing is that if you have a Cl bond, a UV light is going to come in and it's going to break that bond. UV light is going to, in the upper atmosphere, you have strong UV rays. So if the molecule manages to go into the upper atmosphere, and it only happens if it manages to go into the upper atmosphere in the first place, the bond is going to break and it's going to break homolytically. The electron, one of the electrons would go back to Cl, the other electron would go back to carbon. The electron is going to okay, so So the bond breaks homolytically, and you get radicals. Radicals are produced. What radicals are produced? It's going to be F, and Cl. That's going to be your radical, and the other radical would be a Cl radical that's going to be produced. Radicals are molecules with unpaired electrons. Yeah, simply they don't have complete outer shells. So if they don't have complete outer shells, the radicals would attack uh, anything that moves or that's around them. Because chlorine wants to make a bond, it needs one electron. Right now, it has seven electrons. Its bond is broken. So it would, if it sees ozone, it's going to react with it to form a ClO radical. It's going to pull one oxygen away from the ozone, and ozone would break into O2. So out of the O3, it's going to pull one of the oxygens. Now, in this case, the oxygen doesn't have complete bonds because, I mean, the Cl got its electrons from oxygen, but oxygen is used to making two bonds. It needs two electrons in its outer shell. So there's one electron still missing. So the oxygen is now a free radical. So now this OCl radical, what it would do is it would attack the ozone again. The oxygen in OCl would try to bond with the ozone, and that would result in the formation of two O2 molecules. And a Cl radical would be produced again. So if it's produced again, it's going to just repeat the whole process. It's going to attack more ozone molecules, and the end result is that if you add up both of these equations, the end result is that the overall reaction is that O3 is getting converted into, or two O3 molecules are getting converted into three O2 molecules. That's that's the end result. You can even add up the equations. This is two O3 molecules. On the right side, there are three O2 molecules. The Cl radicals are continuously being regenerated. It got used up, then got produced back again. Uh, so that's not written in the equation. Same is the case with OCl. So these radicals, they keep on destroying ozone. And once ozone is destroyed, there wouldn't be any UV rays reflecting off the ozone, and they would be able to reach the Earth's surface. So that's how CFCs destroy ozone. Is this clear? I guess it's clear.
Yes.
Mohammed, is this ठीक? So what's next is not
So,
next. Yeah.
so what do you call the equation? Is it like some a form of like free radical substitution?
That's it. No, it's just free radical. I don't know what it's not. It's not really substitution. Like it's just free radical. Like I mean, it's not called anything at the moment
So,
because
so free
because
radical substitution is
but
only for the alkanes, right?
like it's there's three things, right? There's I mean it is free radical, right? That's for sure. But there are three things. There's addition, there's substitution, and there's elimination. ठीक है? There are three types of reactions. Addition is when something gets added to it, or when two substances get added. Like in alkenes, you have addition. Substitution is when one gets knocked out and another takes its place. And elimination is when a molecule is produced from a bigger molecule. So this kind of looks like an elimination. But I'll just check. I'm not sure what it's called, and you don't need to actually know this for AS. But I'll just get back to you on that. Okay? I mean, it's free radical, but we're not probably substitution. I think it's substitution.
Okay.
So next one is uh, about replacements. मतलब ये तो this is clear that we need to replace CFCs. ठीक है, that's for sure. Stop using CFCs. You try and figure out another solvent. Uh, Now, what could be another solvent? Another solvent could be you use hydrocarbons. Example is butane, C4H10. That's a liquid, a volatile liquid. You start using butane. Quickly tell me what's the harmful effect of using butane? Anyone? Man, what's wrong with butane?
It like undergo free
It's
radical
flammable.
substitution.
हाँ ठीक है, number one is flammable and it would explode. ठीक है, so if imagine a refrigerator with butane in it, and it obviously has electrical contact, and there's some leakage, and some of the butane starts escaping. You're going to have fire, and it's going to explode. So this is explosive. Or you could use you could use halogenoalkanes. So you could use halogenoalkanes without the Cl, ठीक है. Just 1 minute, ठीक है. Let's wait for the azan, ठीक है, just 1 minute. अच्छा, so we were talking about replacement. So you had halogenoalkanes without the Cl, ठीक है. Just have a halogenoalkane with, but make sure it's non-polar. Because most halogenoalkanes are actually polar. You don't want them. You want an unreactive liquid, a solvent. So make sure it's non-polar and all the dipoles are getting cancelled out. So what's wrong with the CCl bond? What's wrong with the CCl bond is that the CCl bond is bond is weak compared to a CF bond or CH bond. So the whole problem is with this CCl bond. It's kind of weak and it breaks easily. So it would be better if you don't have Cl in the halogenoalkane. Uh, so that's pretty much it. Okay, that's all. Just replace the CFCs with hydrocarbons, but they are explosive, or with compounds with halogenoalkanes or halogenoalkanes that don't have Cl. Okay, is this clear? Is this clear, Mohammed?
Yes.
Yes, sir.
ठीक है. अच्छा, the next thing, there's still we still haven't done completed uses. The other use that we have is uh, about polymers. ठीक है, polymers that contain halogenoalkanes. Or polymers that are made out of halogenoalkanes. The first one is PVC. Number one, that's polyvinyl. So that's polyvinyl chloride. Uh, and the molecule is this one. It's this is the monomer. It's H, and there is one Cl in it. And these monomers, they get polymerized. So there would be lots of monomers, and they would all have. They're going to all have Cl in it. So so the monomer would repeat thousands of times. So PVC, you make a lot of things out of PVC now. Even windows and doors are made out of PVCs. Right at the beginning, pipes were the first thing that were actually. Now pretty much the whole house is made out of PVC. Even tiles. So that basically means it's a very tough substance. Like 10 years ago, they started making windows out of. I mean, previously, initially, houses were made from windows that were made out of steel. Then they switched to aluminium because aluminium was light and did not rust. Now they've switched to PVCs. They've made better PVCs, and now even windows and doors are made out of PVCs because they're long lasting. So what's so why are PVC molecules so strong? The reason they're so strong is that if you have a strand of a polymer and another strand, then What does the chlorine do? The chlorine makes the molecule, the bond polar, which means the chlorine would have partial negative and the carbon over here would be partial positive. So if the strand has a lot of C and Cl bonds, uh, if it has a lot of CCl bonds, they would attract each other a lot more. Uh, so that is why PVC chains, they attract each other very strongly, and they're very strongly bonded to each other. ठीक है? Is this clear? Is this clear?
Yes.
ठीक है. Second one, that's a PTFE molecule. So that's the second one. It's a PTFE molecule. What happens with a PTFE molecule? That's known as polytetrafluoroethene.
Is it like polyester?
The PTFE is not polyester. It's polyester is completely different. Okay? We're not going to study actually polyester. That's in A2. Uh, that's a condensation polymer. It has ester linkages. PTFE is known as Teflon, and that's your non-stick that's used in your cooking utensils. So it's your non-stick in your cooking utensils. That's what PTFE is. It's similar to the one above, except that all of the bonds are fluorine. Now, if all the bonds are fluorine and it polymerizes, so lots of monomers, they add up, they join together, and there's N over here. So lots of monomers, they join up. Now, this would be a highly non-polar molecule because the dipoles would get cancelled out. I mean, fluorine is highly electronegative. Fluorine is going to try and pull the electron upwards, but there's another fluorine that's countering that. It's trying to pull the electrons downwards, and the dipoles cancel out. So the dipoles, they cancel out, which is why the first thing, it's non-polar. But the additional thing is that the CF bond is very strong because small atoms, they make strong bonds. CF bond is very, very strong. So hence it's also very heat resistant, which is why you can use them in cooking utensils in the first place. So that's a PDFE molecule, and that's the reason. I mean, you must know the reasons. TK, it's not O levels. You know intermolecular forces. You know how properties change. You know about dipoles, so you should be able to comment on the properties of the polymer and how would they change if. So I'll just ask a simple question. What would change if in a polymer instead of the Cl you have an OH? Any idea?
Hydrogen bonds will
So
form.
it's going to be it's going to start absorbing water because it's going to attract water molecules, right? Uh, so you have your foams and your uh, like your washing foams and cloths for cleaning cars, etc. Sponges, they're very water absorbent. Diapers, they're highly water absorbent, so they have a lot of OH groups. So you must know that what would happen. It's going to become strong if the molecule is polar, the chain is polar. If it's non-polar, it's going to be non-sticky. It's not going to attract anything. It's not going to bond with your food. So it would act as a non-stick. It wouldn't attract anything. Plus, the bond is very strong, so uh, it's going to be heat resistant. It won't decompose. It's not going to melt. Like on the frying pan, it's not going to melt. ठीक है, is this clear? Aiza, Zahib, Mohammed, is this clear?
Yes.
Yes, sir.
Yes, sir.
Then so that's it. Those are your users. Uh, a few of the users that need to be mentioned. That's ठीक है, we've talked about freons, deodorants, refrigerants, coolants. They're pretty much the same thing. Uh, there's one I should add, and that's CFCs are also used in anesthetics. And then these halogenoalkanes, they're used in fire retardants. Retardants, fire retardants, especially the ones CFCs with bromine. ठीक है, mostly CFCs with bromine they use as fire retardants. That's another use. I mean, you wouldn't call it a CFC. It's instead don't call it a CFC. A halogenoalkane with bromine. So that's it. So let's. We don't have a lot of time, but we can start a small worksheet related to halogenoalkanes. Okay, let me just open it. ठीक है, I said, but I have an issue with recordings right now. Well, I don't have an issue. It's just that okay, the person who's actually responsible for uploading recordings, he has run away. So just I'm sorting it. Okay, probably this you'll get all the recordings. Okay, just 1 second. Where's Ajay, let me. Okay, this one. Halogen. Okay, this one. Halogen derivatives. So starting with the first one, he's saying what type of reaction is. So what type of reaction is what's happening here in stage two? Huh? What's the reaction that's happening here? So you have now listen, look very carefully. Can you even guess what's happening here?
It's addition, right?
No, it's not addition because it's substitution. I mean, look over here. There were two hydrogens, right?
Substitute one of the H.
So the H got substituted by a bromine. So the H left and the bromine. So it's basically this is happening. There's two carbon atoms. This had three fluorines, and there are two H's and Cl, right? So this H, one of the H got substituted. So that's gone, and it has been replaced by a Br. So it is substitution. So it's now what you have to guess is what type of substitution is this? Like when you have H getting substituted in a carbon chain.
Electrophilic.
नहीं वो तो electrophilic was addition. This first one was electrophilic addition. This is free radical substitution. Okay, if you go back and have a look, I don't know if did we do this in. No, sorry, this is the halogenoalkane. It was the first one that we did. The first one that we did was free radical substitution. Okay, if you have a carbon chain, and if you have H atoms, TK, all H atoms, and you had a radical, like a Cl radical, the Cl radical would come in and would pull
So
one.
bromination mila.
The bromination was with double bonds. You were first. This was the first one. Okay, free radical substitution was the first one that we did. एक second, where's the? वो फिर हम discuss कर लेते हैं. We'll revise that. ठीक है, free radical substitution. We'll go through that. It was the first one, the first mechanism that we did, the first reaction that we did in organic chemistry. Okay, due to UV light, you had Cl radicals or bromine radicals. ठीक है.
Oh, say it.
Or the Cl radicals would come in. they were created because of UV light, and they would come in and they would steal away the hydrogen. So this would become a radical, and then other bromines or Cls would come and substitute it. Okay. So this one is free radical substitution. I mean, it is substitution, but it's free radical substitution. With alkenes, remember it's addition. This first one is addition, or alkenes have electrophilic addition reactions. So the first one is electrophilic addition, where a carbocation was produced. So we've run out of time. We'll go through this worksheet next class related to halogenoalkanes. But a lot of questions would be from the previous topics as well. So, ठीक है, Mohammed. Mohammed, do you have any exam coming up?
I have my mocks in March. So yeah,
Okay.
I had to like finish syllabus and revise also.
Okay. So okay, then let's continue with this next class then.
Yes.
Okay, take
Thank
care.
you.